In this video, we continue our introduction to Python by focusing on scripting basics. Why script? This is a good question to be asking yourself right about now. One way to justify the time it takes to script a task is to look at it in contrast to doing things manually. In this view, scripting wins over time as those who can't script trudge along doing things manually. Let's face it, GIS is hard, and it's made of many different components, of which scripting, also known as methods and procedures, is only a small part. Scripting is a tool that assists and builds on manual methods, and the ability to mix manual methods and automated methods is important as you perform more detailed spatial analysis and produce more complex cartographic products. Learning to script can only make you a more efficient GIS professional. You may be confused about the difference between programming and scripting. Well, certainly it could be considered semantics, but there is generally an understood difference between the two. Typically, a programming language is used to build software components from scratch, while a scripting language is used to work with and automate processes with those components. Called programming languages are typically compiled before running, which is a conversion of the code itself into bytecode, whereas scripting languages are interpreted and converted to bytecode at runtime. There are other differences outside the realm of this class that can be found by a simple Google search of the differences between compiled and interpreted computer languages. In life, we encounter problems every day. The following are steps you can take to systematically arrive at a solution that can be used to help with Python scripting. The steps that are outlined here can be used throughout this course to frame your programming solutions. After you have read or listened to the problem presented, identify your input. Input is the essential information that a program needs to solve the problem. The input may be given by an outside source, like a person using the program, or default values given by the programmer. Identify the goal or objective. The goal is where you define your end result. Sometimes you may have more than one goal, so list each goal clearly. Create a list of tasks to achieve your objective. These are steps required to reach your goal. Make sure you enumerate your steps in order for clear execution. Also, make sure each step is descriptive and clear. Your list of tasks will result in your goal from step 2. When you have finished your tasks, make sure that you have answered the problem and met your goals. This is probably the most important part of the steps, but the easiest one to forget. If your steps from part 3 don't lead to your goal from part 2, then you didn't solve the problem and you should start back at step 1. Here we have an example problem. What if we were asked to calculate and print the average of 3 numbers, 5, 10, and 15? Task 1, identify your input. Our input is the values 5, 10, and 15. Task 2, identify the goal or objective. We need to average the input values. The equation for calculating an average is to add all the numbers to create a sum, then divide the sum by how many numbers you added. Task 3, create tasks to meet the objective. So we will have to first assign values for the input, second, calculate the sum, third, calculate the average, and 4, print the average. Organizing problems into an input, goal, task framework is a start towards creating a programmable solution to a problem. However, it is the creation of an algorithm, more informally called pseudocode, that helps to describe the set of instructions needed to complete a task. Pseudocode lacks the tighter restraints of programming languages. There are some definite rules of logic that should be followed that will help you translate your pseudocode into actual computer code via a programming language's syntax. For instance, there should be clear start and end to your set instructions. Indentation is also important to clearly show the body of the program. Practice using indentation now. It will become vital as our programs get more complex. Also note that when calculating the average, we divide by 3.0 instead of 3. This is vital to ensure the accuracy of our result. This program starts by setting the values of the three numbers, which are needed to be able to calculate the sum. Ensuring sequential order is vital to get the result you expect. A more visual way to see the behavior of a program is a flowchart, which is appealing to the visual learner. A flowchart uses symbols and shapes to represent an algorithm. Pseudocode can be translated into a flowchart and vice versa. Now let's examine a more visual solution to the pseudocode problem. The flowchart begins with start and ends with stop, as all programs will. Following the start, all assignment statements are in rectangles, and the print statements are in parallelograms. Note that all statements must be placed in their appropriate flowchart symbol, with arrows showing the direction of the execution. Syntax differs based on the type of programming language that you are using. Syntax is text, numbers, and symbols entered via an interface for the programming language's compile or interpreter. This can be as simple as Notepad or more sophisticated within an IDE. This is a screenshot of IDLE, which ships with Python. It combines both the interactive Python interpreter and the script, which is a common way of using Python. We also see the Python script for the problem we've been working on throughout this video. Note that the benefit of using Python is that the syntax is very similar to the pseudocode that we are using. In the next video, we will examine how IDEs improve programming experience.